So we're still in section 14.7. These are all passive filters. We're not using op-amps just yet. And last week we saw low-pass filters. So by taking the voltage across the resistor and doing the transfer function over the for this voltage over the input voltage, we see only the low frequencies coming through, and the high frequencies all get rejected. So the gain is much lower than 1. Same thing for an RC circuit if we get the voltage across the capacitor. Now what happens is really these two circuits are the same. We're talking about high-pass filters now, and if you get the oscilloscope or whatever probes you're using in PSpice, first you measure across the capacitor, you see only the low frequencies. What happens is across the resistor, you see all the high frequencies. So really you could see this as a classifier, right? So you put in a ton of different frequencies. So all the low frequencies stay here, and all the high frequencies stay here. So you're filtering, or you're making your Bode plot split into low and high frequencies. We're going to also talk about bandpass in a second, and they're usually second order filters. But for now, let's do the transfer function for this. And then the same thing happens for an RL. So if I take the voltage across the inductor instead of the resistor, I'm really looking at the high frequencies here, because obviously the low frequencies were across the resistor. So just like we've been doing, the H of S here is going to be the voltage across the resistor over the input voltage. And here I'm just calling this high pass to underscore that what is in the resistor is the high frequencies, but because the low frequencies get trapped by the capacitor. So this is a voltage division, as you probably now are sick of looking at. So it's the resistance over the impedance of the resistor plus the impedance of the capacitor. And in general, I want transfer functions to be of the kind of numerator over denominator without any other fraction. So I'm going to multiply both by SC here. So H of S will be SRC divided by SRC plus 1. And so this is my final H of S. Of course, S is J omega. If I were to plot a Bode plot here, what happens is there's a 0 in a pole, and the 0 is the one starting at 0. Take a look at our at the video with the Bode plots. But then what happens is that 1 over RC, this is my corner frequency. So for omega, when omega is 1 over RC, this equals 1. So this is my cutoff frequency, or in this case, it's more corner frequency when the pole starts making an effect. So it's a minus 20 dB for the pole, but I had already a plus 20 dB on this side. So now this is a 0 or a gain of 1. So as you see here, this stays at 1. So this is a typical Bode plot for a first order high-pass filter. So very similar analysis for a high pass. I'm already at the 5-minute mark here. So very similar analysis for an RL circuit. I'm going to let you do this as a in-class exercise. So I'd like you to show me how this is a high pass by doing the transfer function and sketching out the corner frequency is different than 1 over RC. This should be reminiscent of the first order circuits we did in 285.